Welcome to the DIY Honda Garage channel. The DTC P0716 pertains to the Input Turbine Speed Sensor A circuit, which monitors the rotation speed of the input shaft and turbine within the automatic transmission of the Honda Civic model years 2011 to 2015. This error indicates a range or performance problem within the circuit associated with this sensor. It is crucial to recognize that this issue is strictly electrical in nature, indicating a potential malfunction within the wiring or connections rather than a mechanical failure in the transmission gear itself. The Input Turbine Speed Sensor plays a vital role in ensuring proper transmission operation, providing critical data to the Powertrain Control Module, PCM, for optimal gear shifting and engine performance. The sensor is located within the transmission assembly, typically in proximity to the torque converter. Understanding this portion of the vehicle's transmission system is essential for accurate diagnostics and effective repairs. The components affected by DTC P0716 primarily include the Input Turbine Speed Sensor, A, and the associated circuits within the transmission. This sensor is essential for measuring the speed at which the turbine and input shaft rotate. Its data is critical for the PCM, allowing it to make informed decisions regarding transmission shifts and overall performance. The Input Turbine Speed Sensor is typically located in the transmission assembly, often near the torque converter, where it can accurately measure the rotational speed. Electrical signals are sent from the sensor to the PCM, and if any discrepancies or performance issues occur, it can lead to a failure code like P0716. Understanding the location and functionality of these components is vital for diagnosing issues and performing repairs correctly. Possible causes of DTC P0716 can be outlined explicitly as problems associated with the electrical circuit of the Input Turbine Speed Sensor. The first and foremost issue could involve wiring or connector damage that disrupts the signal sent to the PCM. In many cases, frayed wires, corrosion, or loose connectors can lead to inaccurate readings or complete signal loss. Additionally, the speed sensor itself may be faulty or malfunctioning, producing inconsistent or erroneous data about the turbine speed. It is important to perform a thorough visual inspection of the wiring and connections, as well as a functional test of the sensor. Each of these potential causes must be examined diligently to isolate the issue effectively. Symptoms associated with DTC P0716 can significantly impact driving experience and safety. Drivers may notice engine performance issues, including a lack of power or rough acceleration. Unpredictable shifting may also occur, where the transmission could shift too early, too late, or erratically, affecting drivability. In some situations, the transmission might exhibit overheating, which can be dangerous and lead to further damage if not addressed promptly. If these symptoms present themselves, there is a high likelihood of circuit or sensor problems affecting the vehicle's operation. Hence, addressing these symptoms swiftly is crucial to preventing more severe mechanical failures down the line. The first step in troubleshooting DTC P0716 involves starting with the vehicle's ignition system. Turn the ignition switch to the on position, or press the start-stop button to set the vehicle in the on mode. Once the ignition is on, utilize the Honda Diagnostic System, HDS, to clear any previously stored diagnostic trouble codes, DTCs. This clearing process is crucial as it allows for a fresh start in diagnosing whether the DTC is a persistent issue or an intermittent fault. After clearing the DTC, raise the vehicle securely on a lift. It is essential that all four wheels are elevated and allowed to rotate freely for the next steps in the troubleshooting process. After ensuring the vehicle is securely elevated, start the engine and allow it to reach operating conditions. It's important to disable the Vehicle Stability Assist (VSA) system by pressing the VSA off button, since this may interfere with the testing process. Subsequently, you will need to conduct a test drive of the vehicle at speeds exceeding 19 miles per hour, or approximately 30 kilometers per hour, for at least 30 seconds. This test drive is critical as it allows for the input turbine speed sensor to operate and relay information to the PCM. After the test drive, come to a complete stop and ensure all wheels have ceased rotation before proceeding to check for any pending or confirmed DTCs using the HDS. In this step, check if the HDS indicates DTC P0716 as pending or confirmed. If the DTC is present, you have successfully duplicated the failure condition, allowing you to proceed with further troubleshooting. However, if the code is not indicated, this may suggest an intermittent failure, implying that the system is functioning correctly at this point in time. If the freeze data or onboard snapshot of this DTC was recorded, it's prudent to attempt to reproduce the failure under the same conditions documented. This stage is indicative of how the system is reacting and ultimately narrows down the issue at hand, facilitating targeted repairs. Next, you should focus on the torque converter turbine speed sensor. With the vehicle still elevated, rotate the front wheels while the shift lever is in the drive position. Use the HDS to compare the RPM, revolutions per minute, of the torque converter turbine speed and the input shaft drive pulley speed as recorded in the data list. It is crucial that these two RPM figures are closely aligned. If they are approximately the same, this indicates that the torque converter turbine speed sensor is functioning correctly. However, if a significant discrepancy exists between these speeds, it suggests that the turbine speed sensor needs replacement. Understanding these RPM values is critical to verifying the health of the sensor. If the speeds from the torque converter turbine speed sensor are in alignment, the next step is to ensure that the powertrain control module, PCM, is updated. For vehicles with outdated PCM software, updating the software may resolve the DTC P0716. Alternatively, if after updating the PCM, the DTC disappears, you can consider the troubleshooting complete as the vehicle is back to proper functioning. If a known good PCM is substituted and the DTC P0716 clears, you should replace the original PCM to ensure long-term reliability. This step emphasizes the importance of keeping software current and accurately diagnosing electronic components most effective. After all repairs and adjustments have been made, it is crucial to conduct a final verification to ensure the DTC P0716 has been resolved effectively. Begin by retesting the vehicle's performance under similar conditions that initially triggered the code. After a substantial test drive, check the HDS once more to confirm the absence of DTC P0716 or any other related codes. This verification step is vital as it provides assurance that the issue has been adequately addressed and that the vehicle performs as desired. Proper confirmation closes the loop on the diagnostic process, ensuring that the repairs executed have been successful and the driver's confidence in the vehicle is restored. To prevent recurrence of DTC P0716 and maintain optimal vehicle performance, regular preventive maintenance is advised. Start by conducting thorough inspections of the wiring and connectors associated with the input turbine speed sensor. Ensuring that these components are free from corrosion and damage can prevent future circuit issues. Keeping the connectors clean and securely fastened is equally important, as loose connections can lead to faulty readings and malfunction. Additionally, routinely updating the PCM software with the latest versions can significantly enhance the PCM's ability to manage operational parameters effectively. Adopting these preventive measures will aid in early identification of potential issues and encourage greater reliability of the transmission system. In conclusion, DTC P0716 highlights the importance of understanding the role of the input turbine speed sensor within the transmission system of the Honda Civic from 2011 to 2015. Recognizing that this issue is electrical rather than mechanical sets the stage for proper diagnostics and effective repairs. It is essential to meticulously verify all repairs through rigorous testing to ensure that the code does not reappear. Furthermore, adopting preventive maintenance measures can significantly reduce the likelihood of future occurrences and promote ongoing vehicle reliability. By following the structured troubleshooting steps and understanding the fundamental components, you can maintain the functionality and performance of your vehicle's transmission system effectively. Please like and subscribe to the channel. See you next time.